Here we've got a rocket being launched into the air with an initial speed of 30 meters per second. So we're assuming it starts at the ground, so I've labeled the ground level as a height of 0. And my rocket I've just drawn as this little triangle. And then it flies into the air under a free fall. So we have to make a few assumptions here about the nature of the rocket engine. And we're assuming the engine burns out almost immediately, but it manages to get it up to a 30 meter per second speed while it's very, very close to the ground. So it starts with kinetic energy at the bottom, 30 meters per second. And then obviously as it rises into the air, it's slowing down, and we want to figure out what its final velocity is at the 15 meter mark. So notice I've written my conservation of energy equation out already. My overall energy before always consists of potential, kinetic, and if there's any additional forces that act in this question, any additional thrusters or anything that act throughout, that's called work in. So it's my input energy. It adds to the overall energy. And all of that gets converted to potential, kinetic, and if there's any heat generated, that's on the right-hand side of the equation. So let's go through and itemize what we don't have. Well, we start at the ground, so we have no initial potential energy. We've already talked about the thrusters of the engines. They get worn out almost immediately, so there's no work done, no additional work as it flies through the air for 15 meters. At the final location, it definitely has potential, so I'm going to leave that. It's in motion, so it definitely has kinetic, so we'll leave that. But it does say that air resistance can be ignored right here. So we're going to scratch off any losses due to heat. Any heat will not be generated. So now let's go through and put in our equations. I start with only kinetic energy, 1/2 mv initial squared. It gets converted to, so equals, potential, mgh final, and a final kinetic energy, 1/2 mv final squared. Notice again, there's a mass in every single term, so I can cancel off the masses. Once again, the masses don't matter. And we want to solve it for V final. So let's get rid of this GHF first. I like to move big things around all at once. So the left-hand side was 1/2 V initial squared. If I want to get rid of the GH all at once, I just subtract it from both sides. So we're going to get minus GH final equals 1/2 V final squared. Now to get rid of that half, it's probably easiest just to multiply everything, both sides, by 2. But I've got to multiply everything by 2 on the left. So on the right-hand side, the 2's will cancel, so I'm left with V final squared. And on the left-hand side, I've got to feed this 2 through. And when I do that, you can see in the first term, I get 2 over 2 V initial squared, which is just VI squared, minus, if I bring that 2 through, minus 2GH final equals V final squared. So the last step when I'm solving this for V final is to take a square root of both sides. So V final is the square root of V initial squared minus 2GHF. Now when I put the numbers in, and I'll just do it in blue because I'm running out of space, I get V final equals V initial squared, 30 squared, minus 2 times 9.8 times H final, which was 15. But I do have to take a square root of that whole thing. And when I do that, I end up with 24 meters per second. So by the time it reaches that 15 meter mark, this rocket has slowed down to a speed of 24 meters per second. Now in part B, it says do the same problem, but this time use your knowledge of kinematics. Well, kinematics might even be easier for this particular question. We just set up all our variables, V initial, V final, acceleration, time, displacement. V initial was 30, and it was up, so it's a positive 30. V final is what we're looking for. My acceleration is the acceleration due to gravity, negative 9.8 meters per second squared. I don't know T, but I do know it's moving a vertical displacement of positive 15 meters. So since we're trying to find V final, avoid equations with T in it, and I get V final squared is V initial squared plus 2AD. Now if I put in the numbers, V initial squared is 30 squared, and plus 2 times negative 9.8, and my height is 15. That's all equal to V final squared. So when I work it all through and solve it, I get exactly the same answer, of course, and I get 24 meters per second for V final. Just one thing to notice, this line right here is the same as this line right here. So it makes sense that you get the same final equation, as we should, just two different approaches.